Okay, so we got an illustrious panel of white men here talking about components and modules. So we're starting with Ian Feather from Shipstead. And then we got Christopher Shadow from Facebook. So anything you have to complain about, like the heating of the room or something like that, he can deal with that. We got Guy Bedford from Verve Interactive. And we got Kelly Delumeau from Financial Times. Is it me, or did Financial Times get on every panel somehow? I don't know, they might know the organizer. And Alex Russell from the Dojo Foundation, Google. So we're going to talk about components and modules, and to kick us off, I think Guy should take the stage and show us your slides.
So it's incredibly difficult to give an unbiased opinion in this space, and I'm full of my own biases here. So I'm going to do my best to give you an overview of components and modules as objectively as I can from the perspective that I see it. I think we all have a fairly intuitive sense of what a component is at a design level and how it can be used to split up the UI. A component is it's a UI encapsulation that allows code structure and code reuse and portability. So the thing is that with components, you have to deal with a number of different environments. You have to make these components work in different browsers. You have to make these components work with different accessibility requirements. They have to be responsive, potentially, and also handle different input devices. So dealing with touch events, and so it sort of crosses all these web development problems. And this is the thing about the component boundary, is it crosses a lot of issues. So there's a number of features that can be desirable for a component to have. One is composability. So the ability to build a component out of lots of different components, and you can create these higher level components. And as soon as you've composed these components together, another thing you have to deal with is how you handle, if you're dealing with data flow and information between components, how do these components talk to each other? And what's the information architecture of that composure of your components? And then the other thing that's interesting around components is how you actually get those components to display to the user. So client and server rendering is a big thing at the moment, and making sure that you can equally render these components within the browser and within the server as well. So the component boundary, as I mentioned earlier, if you look at a component, if you consider the portability of a component, one way of looking at the portability of that component is to say, well, if I want to move that component outside of my website, how many touch points does it have in that boundary that you have to move to be able to say that component is fully encapsulated? And that boundary crosses the HTML of the component, the JavaScript of the component, the CSS, the URLs used in the component. So if you want to have component libraries and be able to swap out components, thinking of that boundary is a very, very good way of analyzing how good a component model is. The other thing is we should try and avoid making this about web components versus React, and really understand that they're completely different systems dealing with components at different level. Web components have a completely different meaning of the term components to a React component. So it's worth bearing that in mind as well. So I'll start with web components. As we know, we've got custom elements in the shadow DOM, which really form an encapsulation at the DOM level of your component. So you can write these components into your page by just writing an HTML tag. And the power of that is that anyone can do it. You don't need to know a lot of languages on the web. You just need to be able to create a tag to put this web component in there. Wilson Page wrote an excellent article recently about the state of web components. I highly recommend you read it. To summarize incredibly briefly, some of the areas of contention at the moment at the specification level, dealing with custom elements, how those elements upgrade. So when you just write that tag in the page, we'll render pages immediately, and the component might not have fully loaded. So how that upgrade happens, and at a DOM prototype level. Also with Shadow DOM, there's still some debate over how exactly you select the injection of the Shadow DOM, and there's still some consensus that needs to be made in working that out. So the question is, like, with these things going on in web components at the moment, is it showing that the specifications are coming together and the browser vendors are talking to each other and working this stuff out, or is it a sign that there's problems and we should be wondering about this? So it's be interesting to discuss that. And then HTML imports is the other side of web components. So HTML imports allows you to just include a component with a single import tag. And you can compose them and have lots of components relying on other components. When you do this, you effectively assume the URL structure of your app. So if you want to be able to consider the portability of components at the HTML import level, it's the URL structure within those components that has to be assumed. So, for example, your URLs that reference images in that component, JavaScripts within that component, they will need to move with that component if you want to maintain the portability. All right. So the other thing with HTML imports is they're traceable. Because they use URLs as the identifier, you can actually trace through these HTML imports and then optimize them for production. So optimization techniques is either prefetching techniques or concatenation techniques. And then React components, as we all know, they've significantly altered the way we approach component-based development. And the two important features of React components that I just wanted to cover very quickly was the fact that when you consider the component boundary of a React component, it's got a very small component boundary. You can represent that component by a single binding in JavaScript. And that's an incredibly powerful thing. That arbitrarily composed applications can be represented by a single binding. The other aspect of React components that I find really interesting is the server and client rendering property. That you can naturally have these applications that are going to work with full SEO support and then also be able to support offline rendering workflows. The standard techniques with React components for sharing them and distributing them and managing that component interchanging seems to be kind of like NPM package management workflows, potentially with Webpack as well. Is this forming the new bar for how we do front-end development and share components? And if so, are we setting that bar too high to expect people to know all these technologies, be able to use ES6, and be able to have package managers installed? And like Angular, was a lot of the success of Angular dependent on the fact that it was so easy to include these components just as tags in the DOM. If we expect everyone to be using package managers to install these things and use these things, is that setting the bar too high? One of the areas of development in React at the moment is a lot of interesting stuff going on with how they handle style encapsulation. So it's a sort of problem of CSS that in CSS it's a global namespace. CSS classes can collide, they can clash. And how you encapsulate your styles along with your components. And there's various techniques. Christopher has a good presentation on React, CSS, and JS on SlideShare, which is really a good covering of these points. So what are these style encapsulation? Where is the style encapsulation going? And should we be looking at how we can improve these techniques? So module loading. With the growth of ES6 modules, if you want the browser to be able to natively load an ES6 module from within the browser, you need to have a way for the browser to be able to locate that module and know where to find it. And this kind of leads to the development of this module loader in the browser. So there is a specification, a what-works specification for how you can load modules in the browser, and this is under active development at the moment. And it's through this idea of a loader pipeline, that when you write your import statement inside of a module tag, a loader pipeline can try and work out where to find that module. And one of the principles in the loader pipeline is the principle of being able to resolve a dependency without needing to know exactly the full URL to that dependency. And so this is an interesting property. We used it in NPM in CommonJS. You just say, I want to load Angular. And you don't have to think about where exactly that module is located. There's a resolver that's hooked in the browser that'll know where to find that module. And so that's a really interesting property of module systems. And then they also offer the ability to have more hooks into the pipeline, potentially for transpilation workflows as well, which is a very interesting area. Not the only way of doing transpilation at all, but certainly an interesting area of development. And modules, just like I mentioned for HTML imports, the optimization workflows around them are very much the same. You can trace your module tree. So because you can see every module has a reference to every other module, you get this trace. And once you have that trace, once that trace is exposed, the two techniques of optimization are concatenation and prefetching. I wanted to mention this very briefly because I don't know that it's getting enough attention at the moment, and I thought it would be really interesting to share, is the idea of CSS modules. So this is one way of looking at that problem of CSS modularity. In web components, you have this tag name, but these tag names are in a global namespace. And how do we prevent against collisions? And one idea in Webpack at the moment for CSS styles, sort of more related to the React workflows, is this idea that you can have a class name within your actual CSS file that's not a string, but more like a symbol. And the idea is that if you load your style sheet from within the module system, you load this class name symbol, and that symbol only resolves to a class string at the runtime point. So what that means is your class names can be assigned in a way that they avoid global collisions. And in production, they can also be optimized. So there's been some work between Browserify, Webpack, and JSPM recently. Glenn Madden, Mark Daglish, and Tobias from Webpack. And they've been sort of working on these ideas in CSS. And could something like this be turned into a specification and solve some of the problems we have around modular CSS? Do we need to be worrying about this global name collision problem in this way? All right, so that's kind of most of it. Going forward into the future, will these component works that we're doing, will they converge and reach a point where we have agreed upon component conventions? Or is the problem space too large and difficult that we'll always be evolving new techniques, and that's just the way the web is? And depending on which way that goes, it'll have completely different consequences for the way we look at the web in future. And it's also worth thinking about some of those consequences of a componentized web at the various levels for users, component developers, component assemblers, for design, and for the web itself. Great. I'll pass back over to you, Christian. Okay.
Thank you. So, simple and succinct, not at all competing models there that we have to talk about. It's the tectonic shift of web development that we wanted, that was easy to achieve 3 years ago. So we have 7 questions that we chose from, and I'm not quite sure if they're going to show up or not, but I have them on my phone somewhere if I manage to get this Android phone that was not Google's. Okay. I think one of the first ones that I had was from Bruce Lawson, who's actually here, so he could ask it, but he uses foul language, so I'm not going to allow that. Some vendors want to drop the ability for components to inherit and extend existing HTML elements. Button is unicorn button. And is it right to abandon progressive enhancement and built-in accessibility in order to expedite implementation? And I agree with that, to agree with that question, because to me, for web components, it was always like what HTML didn't have, we can put on top of it. But it seems we're going away from that. Alex, what do you say?
So I think it's important to understand that web components have, when we designed web components, when we started designing web components, we looked at the problem of, well, you've got a component in library A, and you've got a component in library B, and you would like to use them together. How do you do that? And the answer was you don't. And that is the current state of the art in all of the component frameworks that you might be using in your front-end development today, except for potentially web components. So to solve that problem in a way that let web components actually be first-class citizens inside the DOM, we had to attack it from a bunch of different areas. The first is to be able to subclass HTML element. Obviously, you want to be able to say class blah extends HTML element. What does it mean to extend HTML button element, though? It's an important question, and I think something that we probably need to get an answer to. But HTML button element has a ton of internal state. It has a ton of internal attributes. It has a ton of internal behavior that isn't well explained today in the platform. It's just the sort of thing that if you looked at the internal shadow DOMs of all the different browser implementations of a button, you would recoil in horror at attempting to resolve those today. So that's sort of the root of this question, which is how do you think about taking the divergent behaviors of all of these different browser-provided implementations and then sort of treat them as though they already agreed with each other. One option is to simply say, no, they don't agree with each other. You're going to have to figure out your own way to represent a button or create a button. But we also created, because browsers could do this, we created the ability in Shadow DOM for you to host other elements. So for instance, if you wanted to have a button inside of your element, you could just put a button inside of your element. And Shadow DOM, because we designed these things sort of as separate things to sort of add up to Voltron, hopefully, and not something ugly, if you get them all together, then you can have an element that will, inside of a shadow element, inside of a shadow DOM, be able to do whatever it darn well pleases without having that escape out into the outside world as an implementation detail of how your thing works. The is question is very interesting, and I don't have a strong answer for whether or not it should or shouldn't exist in custom elements. It's attractive right now, but I think it's particularly difficult to say that throwing away is would entirely imperil the accessibility properties of HTML custom elements or Shadow DOM or web components as a total enterprise. I don't think it's true. I think it takes a very narrow view of one specification at a time and ignores what it means to actually add them up and use them together. The real answer is that every component framework winds up having to take onto itself the responsibility for doing the accessibility for every component that it hosts. And that responsibility isn't any lower in a web components world.
Well, we have an accessibility panel coming up, luckily enough, but my colleague, for example, we talked yesterday that you work a lot in a content management system environment world where a web component could be extending things that a CMS is already doing. If we don't have that kind of feature in web components, that will never be the option. You have to put your web components somehow into a content management workflow as well.
Yeah, I think what Alex was saying is that you could host that CMS element, a generated element, into your web component and then benefit from the accessibility of that native kind of CMS generated thing and augment it with your own components. Is that what you're...
That's kind but there's kind of the wrong way around though, because then we basically say the end user or the implementer doesn't know that this is a button, which might not be a bad thing because when you have like UI libraries, it's like 12 divs instead of a button. But that you hide it inside your web component instead of extending the original functionality, I think that's kind of complex way around, isn't it?
It's an important question. The question about what you do in the interim between now and when everybody supports web components has a lot of parallels to how HTML5 elements work today in the wild, where you wind up potentially hosting a parent element, which is the new thing, which has a fallback to a child, which is the old thing. And its lifecycle understands what to do with regards to hosting the old thing, or you wind up understanding how to sort of make them work together. This is, again, the responsibility that everybody who's making a component has to take on, is to actually do the work of testing your accessibility and figuring out which strategy is going to work for you in your browser support matrix. I think that's the high order bit. You don't get away from it by just using web components. You have to figure it out for yourself. There's a great list that Jan, who's been incredibly, I'm going to mangle his last name. But Jan has built this great thing called the gold standard, which is all the things that you should probably be doing if you're building a web component. And if you meet the gold standard, you're going to participate in the system at the same level that HTML does. And if you fail at that, you're going to have built a poor component. So please don't do that.
Okay, let's move that to the breakout or to the accessibility panel. If we can get the next question, please. Because, yeah, or I find it myself again. Okay, with the imminent adoption of HTTP2, concatenating our modules together for production delivery will become an anti-pattern. How are we going to maintain two ways of delivering our applications, i.e. do we optimize for both via content negotiation? Ian, maybe you want to take that on?
Right, so I think in the interim we will have to use content negotiation, we will have to serve two different types. I think they do kind of run in parallel, the web component spec and HTTP2, as in the ideals behind it. The idea that we can, rather than bundling things on a page basis, is actually look at a component level and let that component handle its own dependencies. I think that's a really powerful tool, and will actually will enable us to make better systems, better composable systems. If that's true, or if it becomes an anti-pattern, we still don't really know, because there's a lot of testing to be done with HTTP2. There will still be some areas where bundling will be better. Like having that very small granular cache and being able to only change the tiny parts and flush that cache is really beneficial, but we still have to have a lot of testing around that to make sure it's actually as good as it looks.
Yeah, I think the important point is that it's a new tool, and that doesn't mean that you have to use it, and it doesn't mean that you have to use it, have these two different workflows that need to run side by side and negotiate between. There's also ways to progressively take advantage of HTTP2 features by just bundling less and bundling smaller portions of the app as well.
What I love most about this question is about the imminent adoption of HTTP2. I want to live in that person's life. That's pretty awesome.
I have some concerns with the way HTTP2 is being seen as a magical tool. So one of the issues that HTTP2 doesn't solve is the round trips. And so if you declare your components as dependencies, and if you want to make small components, you're going to have many layers of components that depend on component that depend on component. And anytime you want to fetch all of them, you're going to have to do many round trips. And round trip, especially on mobile, is really slow. It can be 200 milliseconds, 300 milliseconds. And so if you have 500 trips, you have 1 second of delay. And so I don't think there's going to be a way without actually bundling in order to solve this issue.
I disagree with that, because the point is that HTTP2 allows multiplexing. So the latency problem basically means that as deep as your dependency tree is, the browser loads something, discovers it has a dependency, loads that, discovers it. So you get this latency problem going down the depths of your dependency tree, if that's in HTML or modules or anything else. But the point is that if you have tracing techniques that can happen, optimization techniques that can happen at the server side, you can know that tree before it even gets to the browser. And then what you can do is you can apply prefetching techniques. And that's more beneficial, because once you've prefetched and you've got this granular cache that each of those resources is cached individually in the browser, instead of having to rebuild the whole bundle and send the whole bundle, you now just have to send that one file. So tracing and prefetching techniques are definitely the way to go for it.
There's a future also wherein the best HTTP2 servers today already support push. It's possible today on an HTTP2 multiplex connection to push resources into the browser's cache preemptively. And so the best servers today already do probabilistic understanding of the relationships between the set of things that you've already asked for, and will send the associated resources that you're probably going to want without a full RTT, which means that in addition to getting the granular caching and expiry benefits that you were just describing, it's also possible to cut out a large number of those round trips. Now, there's very important details there, and the amount of bandwidth that you've got available at the beginning of the congestion window affects these very sensitively, but a smart server can do a lot better in HTTP2 land than it can in HTTP 1.
So stop using dumb servers. Can we get a microphone to Andy Davies, please, and a microphone to Ben Scott? Are we running down a rabbit hole with these kind of things? Because it seems like we're right now saying okay, that component might have another component inside it that is connected on another 3 components. It seems like we have these Matroska dolls in the web right now, and if those are external components, then we will have the latency problem no matter what server you have, right? Is part of the gold standard not to go down too many levels in your components?
But if the server transitively understands the set of likely dependencies, and by the way, in web components, if you're using HTML imports, we have an additional optimization, which is that we can run the prefetch. We can run the preparser over your HTML imports and start getting requests out onto the wire significantly faster than if we actually had to run the script or actually parse HTML to do it. The preparser, the separate thread that actually runs through this stuff, can do quite a good job of starting to get real
one level of tree depth, right? So.
Or as much as you've got markup already for.
Right.
As much as you've already got in the cache, we can start to understand the tree of.
Okay, Andy, talk to the box.
Alex has partly covered it. One of my questions was, as we build runtime dependencies using ES6 imports, is how does the preparser resolve those dependencies? Or are we going to end up in the same situation as we have with CSS imports, where the browser can't resolve them until it's got the first file? So I think there's some challenges there.
I think in the naive sense, yes, you're entirely correct. So to the extent that you're serving over HTTP 1.1, you don't have modern clients, right? There is going to be a gap in that coverage, and you will have to lean on concatenation and minification in order to reduce the total potential size of that window. But in an HTTP2 world, it's possible to do significantly better. I want to also agree with you, Chris, though, that there are some potential landmines. Right? We're seeing today that if you send a ton of HTTP2 resources down to the client, like our implementation yet still gets a bunch of different headers. Right? We get all these headers, and we have to parse all these different headers for all these resources. That's actually overhead we didn't have before when you were minifying, and it's something that we're actively optimizing inside of our networking stack. So there are areas here where not all the answers are figured out.
Can you clarify what sort of optimizations at the header level are an issue there?
Well, HTTP2 does a bunch of great things. The first is that it gzips all of your headers. It compresses your headers in the wire, and it can concatenate a bunch of them. But you also still have to parse them when you get them back.
Right.
Whereas if you have a single concatenated resource, you don't have to parse them.
Ben Scott from the BBC. Does he have a microphone? Yes.
Yep. This fills me with dread. Having to... So the question here is, do we go down two-routed serving out our application? Because we end up going, right, well, here's one version for shiny new browsers, here's one for legacy browsers that don't understand HTTP2. Having to manage and maintain those two distinct applications that we end up going and sending to people, that's a lot of overhead to actually make sure we can test. We've effectively just doubled the amount of variance here that we have to go and test and look at to make sure it all works. This is a callback to the days when, well, I say the days, we still kind of do this in that we send a separate style sheet to IE8 for wide style parsing, and then we've got these two ways of working out. It's 2 times the amount of testing, it's double the amount of work. Do teams have the amount of bandwidth to go and say, right, well, we're actually going to have to look at these two distinct things, or will people just say, actually, hang on, no, this is too much effort?
That's a lot of questions. So 2-track effort, HTTP2, HTTP1 is what I heard from that, basically. Is that worthwhile? Is it too much to ask for?
So I want to follow up on this, saying that in order to do all of this optimization that you say, the server needs to know all the dependencies in order to prefetch things. So
no, it doesn't. It only needs to be able to watch what it has previously seen.
Okay, never mind.
Okay, so that's the answer. Excellent.
Tooling will save you. I remember when the idea of having something like NPM and build tools and the idea, Dylan will laugh at this. We designed build tools into Dojo and everyone thought we were crazy. Who doesn't use grunt or gulp? Okay, I got 3 hands in this entire room. Everyone's using tools.
We're also at EdgeConf. So I just been at a Joomla event. It's not the same there. So it's quite. That's going back to the complexity of the thing that we said earlier that he mentioned, and it's really a question like, are we? Well, that's a further question, but let's go to Josh Emerson from Mendeley, if we find him. Okay. Wow, the sports thing that people do here is amazing. You again.
Yeah, I know. I'm going to stop asking questions after this one. And I just have to remember what my question was now. Yeah, so it's kind of around education, but if HTTP2 is the way to go and if it becomes the sort of de facto eventually, won't there be a lot of situations where people think, okay, stop concatenating, we just have all our requests on the page, and the way that they've set it up, their server is unable to communicate with the other server that all their assets maybe are on, maybe it's in an S3 bucket somewhere, and therefore they don't realize it, but none of that concatenation is happening, and they just followed some guides that they found online. Isn't that going to be the norm rather than the exception, and it will make for a horrible experience? We'll be back where we were on the web.
So I think, firstly, the way to approach them is it's a progressive transition. It's not like we have to rethink everything right now. But the point is, over time, things will naturally move towards a more HTTP2-friendly architecture. How exactly that looks is still very much being determined. So for people who are writing apps today, certainly you want to stick with your HTTP1 style of doing things. And when people get up on stage and tell you that HTTP2 is the new thing and you shouldn't be using these previous approaches, you should certainly be critical of that. But there's very much a gradient and a way to gradually introduce it. But certainly you need to think about how you're approaching that and make sure that, and not just dive straight in and say, oh, this is going to solve all our problems.
Okay, let's go to the next question quickly before we go to the next, if Jason Brown can get the microphone while we answer that one. Will there ever be a way to make web components render on both client and on server, even if we had the JavaScript backend? That goes back to, I remember, YUI 3 was available on server and on client until people stopped using it. Is that even a question? Does it make sense to have a pre-renderer for web components on the server side?
Yeah, I think that would be crucial, actually, because if you want your first paint of the page, it's quite a mundane question to ask ourselves, but we're at Edge. So if you want your first paint to be really fast, you don't want to rely on blocking imports, although you can async it, but, flash event style content. So I would assume, yes, you probably want parts of your page, what is above the fold. Yes, said it. And so you want that to be pre-rendered, probably. And then the rest kind of asyncly loaded for a better experience. So where is the tooling going to emerge from? I don't know, but we solved that many times in different ways, and I think it's a good thing.
How does React work with that?
Yeah, so the way React works is you can just execute the same JavaScript code and the same render function on the server, and then you send the markups that's going to be generated, you send to the client. And then in parallel, what you can do is also send the JavaScript, like from the CDN, and send the data that has been used to generate this in the first place to the client. And then the client is going to re-execute the same thing, and then catch up, and then all the events now are going to work. And so this is like a really nice way to progressively enhance your page and get a fast CTI.
You seem to be twitching.
No, I mean, I agree with that it's a nice way to work with React. My concern is more to do with web components on the server. On the client, we think of them as having scope CSS. It's shadow DOM. We can't send shadow DOM across the wire. We have to send strings. So that style is then going to seep out, right? We're going to have collisions that we weren't expecting. We're going to have ways of declaratively saying this part is shadow DOM. Because presumably we're going to actually want to fetch that shadow DOM on the server, otherwise we're just rendering empty components.
So in essence, you have an HTML string at the end without the...
Right, and that shadow DOM has become light DOM, or whatever you would call it. And that maybe is fixable by some declarative way of expressing that, but it hasn't been brought up, it hasn't been thought about yet.
Which is a good opportunity to actually... Anybody want to go? Which is a good opportunity to go to the next one.
Just to follow up on that quickly. The power of the shadow DOM is it hides away all those superfluous developments. There's no semantic loss in that. So if you're rendering into a component with a shadow DOM, you're still going to have semantic markup. So when you render on the server, that's the semantic markup.
That's true, but that depends on the authorship being spot on. Like if you have a greeting component and you pass in the data for the name, you might have information around that which you're hiding.
As soon as you have data passing through attributes, right, then you have that issue.
And that becomes an authorship concern.
But everything has data passing through.
But React could wrap that sort of workflow with web components just as easily. So.
Right, but React has, if you're including CSS inside that shadow DOM, React has a way of changing the class names or wherever there are techniques around that, whereas CSS that you would usually author in Shadow DOM would be very sort of globally scoped.
I don't think that's necessarily... I mean, you're sort of presuming a dumb processor, right? You're presuming something that's not nearly to the sophistication of client-side JSX rendering, and I think that, I wouldn't bet against the tools there.
Good. No, I hope not. I hope,
I mean, it's pretty straightforward to do those transforms, mechanically to understand that you would prefix those particular bits of CSS. So it's not magic.
But is this something that is being considered for the V1 for web components, for example?
Well, web components as a spec aren't going to do that, but the tools around them, things like Vulcanize, are already pretty advanced in terms of getting to a place where those optimizations are taken advantage of.
Okay, got a question from the audience.
Alex, so there's a lot of talk about tooling. So obviously, everyone here probably uses tooling in their workflow. But for people who are looking at web components, there isn't a spec that's actually clearly defined. There's different vendors implemented in different ways. So how do you approach tooling when there's not a spec to build for yet?
You invest in it.
That might be the wrong one.
So what if it's the wrong one? I mean, that's an interesting one because the specifications across different browsers have been diverging for a while now, whereas the tooling has to support all of them. Is that putting an extra complexity on tooling, or, as you said, you become part of the specification by showing how hard it is to put it into tools?
It's very much the extensible web problem. Is as soon as you create an extensible web, you need people to extend it. So where does that come from? Well, very few companies are investing in open source. Very few companies are investing in the solutions that build on top of this extensible web. So if we want to have good tools, we need to invest in them.
Okay, we got Paul Irish actually in the question queue. And Jake Archibald vanished from it again, which is not necessarily bad.
Okay, so I've seen a lot of teams that are blocked on the fact of custom elements and ECMAScript 6 kind of having two different directives for importing new components and pulling in, just building the dependency tree. So basically imports versus ES6 modules. How are we going to resolve this before the next EdgeConf?
So I personally think this is a false dichotomy. I think this has been set up in a way that takes a surface understanding of both and says, well, they must be transitively equivalent. And it's not true. It's just fundamentally not true. ES6 modules, the design of which I've also been involved in, is a way for JavaScript, as it's executing, to understand its dependencies and then make some things look asynchronous. And then, at the end of a very long process, hand that off to a network layer, having turned it into a request for a fetch, and then do something with it on the other side of it. HTML imports are a way for you to request some stuff off the network, which will go through a long process, turn into a fetch, and then eventually hand you back something. That bit after the part where each system decides that it wants to make a request and then turn that into a fetch is something that we don't have any control over. There's a missing API in the browser today about what is it that the document does when it's about to issue a request down to the network. And that API is, I think, what we're talking about when we say something along the lines of, well, these two things don't play well together. It's entirely possible to do a completely programmatic version of your web component stuff. You don't have to use HTML imports to use web components, right? Just use ES6 classes and modules. Life is good. Seems legit. You could use HTML imports if you want. Cool. Life is good. Seems legit. If you set these two things up in competition with each other, you then have to understand the system that underpins them and why you can't access them to make them play together. And the fact is that we're missing an API. And if we had that API, we could make them play better together than we do today.
Well, thinking about that, HTML imports to me always seem much more webby than ES6 modules. It's a JavaScript solution for a problem that we included link elements with CSS with link elements. We included scripts with script elements, and we could include templates with also a link element. But the synchronous nature of it was what drove people to another solution. So is there no way of making that with a pre-processor or pre-fetching to make that synchronous? So do we have to throw out HTML imports altogether?
HTML imports and modules, they aren't actually, I mean, they interact fine so far as you can determine how ES6 module tags, just like a script tag, execute within an HTML import. And so that's something that would need to be specified. But with HTML imports, like the question's very much at a spec level at the moment, with Mozilla backing off from that, if we should be putting pressure on that or not. But ES6 modules can interop with them fine.
Yeah.
Jake.
So hello? Yeah, we're talking about using server rendering to hack performance into web components. Shouldn't this have been fixed at a spec level? I know with HTML imports, they block rendering by default. And Ilya Grigorik, Steve Souders, like big performance experts were trying to fight against this, and also, people like me and Remy were also trying to fight against this. Why weren't we listened to?
I think somebody from the tag group should answer that. Yeah.
So first, let me say that I don't make decisions about what everybody else decides to do. I think what has happened with HTML imports, I think, is roughly regrettable. In the sense that we probably shouldn't have added another blocking primitive. I argued with you, I think you'll recall, for that change. There is a tension here between what it looks like when you write out your code and how it behaves in the sort of natural way, you could ask the same question. Should you ever be allowed to have CSS font that blocks rendering? Right? It's roughly an equivalent sort of upgrading operation of your content that happens asynchronously later, potentially. I think I was not happy, but certainly, happier to see that there was an asynchronous flag added, so that the best practice can become always do async, and then style your HTML unknown elements that are custom elements to look like the stuff you're going to do. I think Paul Lewis did a brilliant guitar tuner application which uses Polymer in exactly this way. It takes the stuff on the page, it asynchronously loads everything, it styles it like it's roughly going to look, and then once it pops in, it goes boom, and it's all right there. And I think that's really kind of the sweet spot today.
Okay, we got another one here that I liked. We have to skip one of those just to mess with the people who show the slides. Two-part static analysis by the interpreter of ES6 modules makes it impossible for an async CSP-compliant loader to be written, e.g. an AMD loader plugin analog would need to load and then eval violating CSP. What's the plan to fix this?
So there's a deep question here, which is very inside baseball in the JavaScript spec, which is that the minute you have something like a custom resolver that allows you to do text transformation over the contents of a module, like someone was saying, well, you'll just ask for some NPM module and it goes and gets it, and that means that there's a table that gets consulted about where that thing actually comes from. What's that eventual URL? That process brings in some stuff, and then you do some stuff, and then you hand back the module thing. That process is all programmatic. There is a version of the default loader where all the analysis can be static and one-directional, and that's great. The minute you add a custom loader hook or a custom module loader into the system, those promises break. The short answer is because NPM. And because whenever we've tried to build one of these module systems before, we've understood that we absolutely have to have this sort of custom loader hook in order to make them functional in the real world. So I guess the long and the short of it is, nice dream.
Well, so what exactly, when you're saying things break and moving from programmatic to static loading pipelines, what breaks?
Well, the ability to completely analyze everything about what the behavior would potentially end up being.
But if that resolver is understood on the server as well, then you would have that information.
Potentially, but CSP can't reason about that, because CSP is about turning off features in the runtime, and if you have to eventually transform some code which is going to get evaluated via new function or eval, or turned into a module, which is then going to get interpreted,
it's around
effectively recreated eval.
A custom fetch system, effectively. Yeah.
Am I boring everyone?
So
I think the answer...
Yeah, isn't it a reason for going through the bundling phase on the server? Because it seems to me bundling on the server right now is working, is as fast as HTTP2, even faster, because you don't have to round trips, you don't have the headers and everything. And it seems like we're inventing a lot of new specs, same for web component, React is working on the server. And I don't see the big win that we're going to get out of it. And it seems we've spent the entire time looking at all the deficiencies, all the systems where we have something that works.
But ES6 modules do something very different. I mean, writing your code today in HTML as we have it and JavaScript as we have it doesn't work. Right? We need very large, complicated tool chains because we don't have any built-in modularity in the platform. And so the ability to actually put a thing in a module, put it over in its own file, and then not have to deal with all of its dangly bits hanging out and then potentially stabbing you in the side whenever they happen to come back into life, but through an import statement, is a very nice property, and that's what ES6 modules give you. And so just from a sanity perspective, we absolutely must have ES6 modules to preserve our own ability to write at scale. And so this is a detailed question about what it means to have that system and then have to live with it. And I think the answer is yes, you can do all the server concatenation that you want, and if you're very dedicated about making sure that people can't write dynamic modules or dynamic module loaders inside your system, life is still good. You can do all the stuff that you want to do.
With that dependency, we also need the browsers to understand these things. Otherwise, we will have to do everything on the server side anyways. And I don't see a certain fruit company from California in any way doing that right now, not sitting here, for example, and talking about these things. So changing all the browsers to an ES6 world is going to be a much harder task than actually getting a new, getting what we already have in imports, in HTML imports in some of the browsers.
I think, is the question what is Apple implementing? Because they've done quite well at ES6 implementation so far.
Okay. So, but lots of old Android phones and all kind of stuff. So will we have a world where we will ever be client-side completely with web components? I think we're stuck there quite now.
I think if you try to use custom elements today with one of the many libraries that support them and provide them, Mozilla's Brick, Google's Polymer, I've heard of many others, they all work. You could just use them today, right? Their performance overhead is minimal, and they're fast enough to use. So.
Well, this goes to the next question here. Like, components can make web development significantly easier, but can also have a negative impact on loading performance. What is being done to mitigate that? We talked about that a bit to a degree, but when you said, like, just use a library, for example, I still find that Polymer sites on Firefox are terribly slow, because they do a lot of polyfilling under the hood and because of the changes in the implementation of web components. How can we mitigate that? You worked on, Kelly, you worked on a component library in Financial Times. Do you do something like that as well, or?
Yeah, we provide ready-to-use components that are not web components, but we're really looking forward to that, so that it's even easier to pull them into your application, just throwing a few tags. Whereas right now you have to bring a lot of markup, and we don't have access to that markup once you've put it into your application. And what we do to mitigate that is that by default we give you a few things that are really easy to use. If you want to go the extra step, we let you do everything on your own application, on your own server, do your own minification with those modules. I don't know if that answers the question, but it's like there's something really easy to use. It's not super performant. Then if you want to be extra performant, do it yourself. And I guess the tooling, again, is what we also provide.
Because I feel kind of left behind as a web developer, because when we announced web components, future of the web, like tectonic shift in web development, you can control your own elements, and now 2 years later we tell people you have to use that library or React or that one, and they're all massive libraries, and none of them, as I see, just come with a fix, except for webcomponents.js. All of them come with lots of their own widgets that I should use, and that feels to me going back to like jQuery UI or YUI. What do you think, Ian? Like, can we just give people a fix so they can start playing with this? Because we had this discussion yesterday.
I think that
who builds them live right now?
Right, that's an issue. So we have these libraries are available. Custom elements, as you say, are possible to use right now. People can build things with them. Very few people are. Right. At the moment, we have all the examples come from Google event pages, that kind of thing, Polymer pages. Whereas the innovation in other component libraries is huge. It's staggering. And when you research web components online, there is just a plethora of information, like reams and reams and books of information and talking, and actually very little feedback on use. Very little people saying, I've tried this, I've done this didn't work. For me, I think that we need to push to get a V1 out so that we get feedback back and can actually make this, get people involved in it, get people actually using it.
So to make it a more open process, much like
ship something,
I just wanted to answer the original question. So there are some applications that are built on Polymer 0.5, which had a complete version of the Shadow DOM polyfill. It's a technical achievement of staggering proportions, but it does require some hacky workarounds for browsers that are slower because they don't implement the custom elements in Shadow DOM specs. The new version of Polymer 1.0 does away with that. It uses something called Shady DOM, which is absolutely compatible and works just as fast with browsers that do have Shadow DOM support. It's their goal absolutely to use it when it's available everywhere, but it is significantly faster. So what you've seen in the wild today is a bunch of people who've built sites, large production sites, which may not be exactly what you were hoping for in terms of performance on browsers that aren't as forward-thinking.
Okay. Sebastian Savi of The Guardian has a question, if we can get the microphone to him.
Hello, yeah. So I've got a point where I think maybe one of the problems is that we're trying to solve all problems with one solution, and we say either it's going to be React or it's going to be web components. But there's many different problems, and they have different properties. And I think one thing in this question here is that it says that we make web development easier, and I think that's one thing that web components does that you don't do with React. So I've got an example where we built web components at The Guardian that you can just compose. You write simply a static HTML file, and you can create a live dashboard for monitoring by simply updating the CloudWatch properties and so on. And I've had like backend developers who don't do any Node or any JavaScript do that and compose that. They've got a live dashboard, and it's just a static file. To answer the question of Christopher, if they had to spin up a Node server, they don't do Node, they don't do JavaScript, they do Scala, and then you have to do an isomorphic React app. That's not quite a trivial thing to do. And if you think of new developers, people who just want a date picker on their page, I think spinning up a React isomorphic application is a bit of a high bar.
Yeah,
what do you think of that?
No, we definitely need to work on tooling, but one of the things that I really want is so that like the initial user experience is like good and easy, but everything at some point, like every app or thing becomes bigger, and I really want like this path to be like really good. And one of the things that I see with Web Component and HTTP2 is like the initial experience for the developer like is good enough, but like you hit like all of those like problems when you try to scale, and not even scaling that much. Like if you want to do like multiple pages, or if you have like, I don't know, like all the websites I've seen like using Polymer or Web Component, like they don't feel great at some point. And so I really believe in Web Component. I want it to succeed, but I have not seen it yet. And what I've seen is that React is actually working for big websites like Netflix, Facebook, Khan Academy, and okay, so this is not going to be like the very low end of the website, but like just above. And this is, I think we need to go a bit lower, and this is where we're working on. But like this kind of website and above, like we absolutely, like this is where we want the web to go forward.
I think that's an important point to note that React has a model about coordinating data and coordinating action inside of your application, which is entirely compatible with Web Components, right? You can use Web Components as sort of the leaf in this tree because you're just outputting HTML, and you can sort of encapsulate your behavior at the HTML layer and build a small component there and still use it with React. The beautiful thing that React does from the browser hacker perspective is that it puts very tight constraints on when you're allowed to do work. One of the things that we see with handwritten applications over and over and over again is that people sort of violate the set of things that you need to do in order to keep frame generation under 16 milliseconds every time. And it's really hard to employ that discipline without something that kind of puts you into the mode of, I'm going to move data from here to there at this moment in this thing and just do that. Like, React isn't faster than native DOM, but it keeps you from blowing out your budget in every frame in a way that's really helpful. So, you know, I've seen proof points of React plus Web Components in the past, and I think the way to think about this is that Web Components are just going to be in the water. There's going to be good ones and bad ones in the same way that there are going to be good and bad other things, but a coordinating layer like React is super helpful.
Is it a delay problem? That I mean, Web Components gave us the impression that it's going to be much more performant, much better, much easier to build apps in the browsers, and then browsers didn't agree on implementing them in the right way, or things got differently done. And then a library comes around and says, like, you know what, we'll do it with a library, and it's much easier for you to do. Is it now a time maybe to talk to other library makers, like Angular, for example, to actually use Web Components in their rollout, to try it out what people are using anyways? Because I don't see Angular developers hard coding anything in that. They just use the system, and they're happy with comes out of it.
So again, I think the premise of this question is both loaded and not historically grounded. The folks who started to work on the Web Components project come from library development backgrounds. We all built one. Eric Arvidsson built one. I built one. Dmitry Glaskov built one. Everybody who was early on in the Web Components effort, you know, comes from that background of having built a tall pile of JavaScript, in Arv's case, Clojure, which is what powers almost all Google apps, right? Very large scale frameworks that are powering massive applications, and understanding the limits of what it means to coordinate. It's not about necessarily faster at that performance level, but it's about composition. And I think it's important for us to try to understand that composing things, saying, I'm going to have a boundary between my implementation and my interface, that is the important thing that we were trying to get to. Now, there are lots of other ways to get there, and we've all built other ways to get there in the past too. So these, again, are not exclusive choices that you have to make. I think it's important, though, to focus on what is the interface that I'm being given, what is the level at which I'm expected to coordinate with it, and what is it that I get in return for that isolation? What becomes harder, what becomes easier? That's the choice that I think developers should start to look at as they're building applications.
Robert Knight from Mendeley has a question. If you guys stand up, it's easier to throw the stuff to you, by the way, and find you.
So in terms of the phase, you mentioned that there's been a few people said that web components haven't seen an enormous amount of usage compared to React, Ember, and Angular. So I'm wondering, as someone working on React or people working on other libraries, what is it that you would like to see, thinking of in terms of the extensible web from the browser itself? What would help make a better React library or a better Ember or a better Angular?
Yeah. So one of the things which we would like from the web component, like extensible manifesto, is scope CSS, like scope styles. And this was in Chrome and it was removed, and I'm not sure when it's going to be back. And the other thing is, as you mentioned, like being able to extend the native elements, like button and things like this. Because right now, like there's no matter of React, like we cannot do that. So those are like two big things.
Those are really important. And I think from an extensibility perspective, I think we should admit that HTML has been a massive failure. Right? The fact that there's all this behavior that you can't subclass, that you can't get the mix-in that it derives from. Like, what does an HTML input do? Right, this is an important question that browser vendors have not ever been taken to task to do. We started this project trying to get to a place where we could ask that question with the framework of, well, here's how it works. Now tell us the other stuff that you did inside of this framework. And I completely agree with you that scope CSS is important. One of the things that we have discovered in terms of performance is that Shadow DOM is the performance accelerator for scoping CSS. If you're going to try to scope CSS inside of the global list of styles that you have to resolve, you're always screwed for performance. Polymer applications that are built with good scoped Shadow DOMs go like hell because they're able to scope their CSS recalcs to just being inside the Shadow DOM.
And this is why with React Native we're trying to do inline CSS to get away with all this CSS scriptness.
Okay, we're out of time, so we have a breakout later, I guess. We can ask us more questions there. Drag the people in a corner, don't let them leave, ask them questions. Thank you very much for this.